In this example, from the large data set, the daily mean visibility V for Leeming in May and June 2015 was recorded. The data is summarized as follows. For May, N is 31. Summation of V is 724,000, and for June N is 30, and the summation of V is 632,000. So first we need to calculate the mean visibility. So we start with visibility, and we say for May. So in this scenario, we would have the summation of V in this scenario over, which will be 724,000 divided by 31, which will give us 23,000 in this scenario, 23,354.8. So that's to 1 decimal point. And we do the same then visibility for June. It will summation V over N. So in this scenario we have 632,000 over 3. So that would give 21,066 point. So that's to another single decimal point. For part B, we need to find the mean visibility for the total recording period. So in this scenario, visibility. In this scenario, we have a combination. So that would give us, we add and add the total of numbers. So that would be 724,000 plus 631. So that will give us approximately 22,229.5, and this will be our answer for part B, and these will be our answers for this question. In this example, a small workshop records how long it takes in minutes for each of their workers to make certain item. The times are shown in the table, so each worker and the time it takes for each worker. So first we need to find the mode for this. So in this scenario, we say for part A, you can see that the mode approximately this average occur once to 8, and this is why. So we look at the most frequently used. In this scenario, we have 2 8s. For part B, we need to calculate the mean of this data. So in this scenario, we add the values and also divide them by the number of samples. So in this scenario, we add 7 plus 12 plus 10 plus 8 plus 6 plus 8 plus 5 plus 26 plus 11 plus 9, all divided by 10. So that will give us 102 over 10, and that will give us approximately 10 point. Now for part C, we need to find the median for this data. To find the median, we can rearrange these from lower to bigger. So we have 5, 6, 7, 8, 8, and then we have 10, 11, 12, and also we have 26. So we can see in this scenario, and we also we have a 8 and 9, 2 8 and 9, so 8 and 9. So in this scenario, we can see that the 8 and the 9, they are the middle numbers. So we can see the median is 8.5 minutes. And this will be our answer for part C. Now for part D, the manager wants to give the workers an idea of the average time they took. Write down with the reason which of the answers to A, B, and C she should use. So for part D, we can explain that the median would be reasonable. The mean is affected by the extreme value of 26, and this will be our answer for, and we also need to explain that in this case the mode is close to the median, so be acceptable. But this would not always be the case. So our explanation would be the median would be reasonable, the mean is affected by the extreme value of 26. In this case, the mode is close to the median, so it would be acceptable, but this would not always be the case. And this will be our answer for this question. In this example, the frequency table shows the number of breakdowns B per month recorded by a road halo firm over a certain period of time. So for part A, we need to write down the model number of breakdowns. So in this scenario, we can see that we would have two breakdowns, which will be the common in this scenario, two breakdowns, which will be the model number of breakdowns. Now for part B, we need to find the median number of breakdowns. So that would be, say that the median value is the 80.5 value, which equals to 1. And also for part C, we need to calculate the mean number of breakdowns. So in this scenario, we take each value and multiply each breakdown multiplied by the frequency and then divided by the total of frequency. So in this scenario, we say mean equal 0 by 8 plus 1 by 11 plus 2 by 12 plus 3 by 3 plus 4 by 1 plus 5 by 1, and all divided by, in this scenario, the total of the frequency, which will be 36. So in this scenario, we would have 53 over 36. So that would give us 1.74 breakdowns. And this will be our answer for part C. For part D, in a brochure about how many loads reach their destination on time, the firm quotes one of the answers to A, B, or C as the number of breakdowns per month for its vehicles. So we need to write down which of the three answers the firm should quote in the brochure, which is either the model number, the median number, or the mean number. So in this scenario, we say that the median number, since this is the lowest value. and this will be our answer in terms of taking the lower value, which is the median number, which will be recommended in this scenario, and this will be our answer for this. In this example, the table shows the frequency distribution for the number of petals in the flowers of a group of celandines that calculate the mean number of petals. So we have the table here. So we start with, in this scenario, we take the values and multiply them by their frequency. So we say mean equal 5 multiplied by 8 plus 6 multiplied by 57 plus 7 by 29 plus 8 by 3 plus 9 multiplied by 1. So in this scenario, all will be divided by the total frequency, which will be in this scenario 98, as we add all the frequencies together. So in this scenario, we say the mean will be equal to 618 divided by 98. So that will give us 6.31 petals, and this will be our answer for this. In this example, a naturalist is investigating how many eggs the endangered couple bird lays in each brood cycle. The results are given in this frequency table, showing the number of eggs and their frequency. If the mean number of eggs is 1.5, find the value of P. So the way we would do this, we will take the mean, and for us to create our equation, that will be the addition, the multiplication of each egg number by the frequency. So we have 1 by 7 plus 2 multiplied by P plus 3 multiplied by 2, all divided by, we have 7 plus P plus 2. So we know the mean is given in 1.5, and we would have 7 plus 2p plus 6, all divided by 7 plus p plus 2. So now we will try to rearrange this expression. So we would have 2 plus 13 over p plus 9, and now we will try to rearrange this. 1.5 p plus 13.5. We'll try to rearrange this expression, and we would also have on one side of the equation, and on the other side we would have so apologies. So we'd have 2p plus 13. So now we move the p's to one side and the numbers to one side, so that will give us half p equal half p. We would have p equal, we'll try to rearrange this equation, and that would give us p being equal to 1. So this will be our answer for this.